I get 20 minutes perhaps. Professor Kamrul?
Yeah.
Ma'am?
Yeah.
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 Okay. Is 0 nothing or something? 0, on 0, we know 0 is a number. We get positive numbers from our experience, and we assume the negative numbers, because in our real life, there cannot be anything which doesn't exist. Say, suppose there cannot be any non-existing 5 things which we actually use by negative numbers. We assume the negative numbers as the opposite of the positive numbers, and we assume the number line, and 0 is the in between the number line. Okay. So when we do arithmetic such as 0 plus 0 is equal to 0, 0 minus 0 is equal to 0, 0 minus 1 is equal to minus 1, 1 plus 0 is equal to 0, 1 minus 0 is equal to 0, 0 into 0 is equal to 0. And you see, 0, if 0 is, should I continue?
Yes, you can.
Yes, I think
well, 0 multiplied by any number will result as 0. So in this examples, we see 0 as nothing. In Fibonacci number series, the addition of the last 2 number is the remaining number. So it starts with 0, 1, 2, 3, 5, 8, 13, and so on. In that series, we see 0, 0 plus 0 is equal to 0, 0 plus 1 is equal to 1. That in the Fibonacci number series, 0 is considered as nothing. But in some examples, we see 0 is not nothing, it is something. When we divide 0 by 0, the result shows in the calculator that it cannot be divided, it is indeterminate, because if we divide the 0 by 0, we can get 1, 2, 3, 4, any number up to infinity. So it is not determinate, and we can't have a result. If we divide 1 with 0, if the dividend is 1 and the divisor is 0, we can get result. If we divide it, if we approach from 1, we get half, and closer to 0, we get 1/4, 1/8, 1/16, and so on. But we cannot reach the 0. Actually, we end up in infinity. So it is undefined, and result is shown in the calculator. Okay. When we multiply anything with 0, we get the result 0. So in these cases, we see 0 as something. Even in the number line, if we see, look, 8, 4, 2, and 0 is the even number. So 0 is an even number, so 0 is not nothing in this example. In the set theory also, 0 is not a null set, it is a set. Whatever it is, Jarmiro reduction or von Neumann reduction doesn't matter. We see 0 as something, it is not empty set, okay. If we consider this example, you see in 2B, we see 1 divided by 0 is undefined. Okay. 1 divided by 0, when 0 is nothing, then the result could be 0 and 1 from different perspectives. If we consider the result, 1 divided by 0 could be 0. Its rationale is that if you have one thing and if you don't give any part of it, then I have got nothing. So the result is 0 from your perspective. From common sense perspective, 1 divided by 0, it could be 1 as well. The rationale is that if something is subtracted by nothing, then that subtraction will be meaningless. It will create no change in the dividend figure. Here the dividend figure is 1. Suppose I have one thing and I have given you nothing, then you would continue, then I would continue to have that very thing intact. So if we know division is a form of, subtraction, and multiplication is a form of addition. So if I subtract 0, then it will mean nothing. So we see that whatever is fixed by mathematics, using our rationale of common sense, we can have some different results, or we can think about it. Next, come to the point why 1 divided by 0 is equal to no result or undefined is determined by mathematics, because I have said in point you see 2 point B, that if we start from 1, we come closer to 0. Actually, we cannot come closer to 0. It is 1/2 to 1/4 to 1/8. It's up to infinity. So near to 0 is considered as 0, and absolute to near to 0 is considered 0 in mathematics. If 1 is divided by 0, and if the divisor 0 is approached from the dividend 1 side, যেভাবে আমরা 2.b তে বলেছি, then the division will be infinitely smaller fraction, ever ending, okay, of the integer. In such situation, they consider near to 0 as 0 and near to infinity as infinity. On basis of this, they claim that 1 divided by 0 is infinity. That means it is meaningless. Mathematicians also do use the use of limit in a functional approach. When suppose the result is 4.999999, they consider it as -5, and the limit of 5.000001, they consider it as +5. The problem of this assumption is that there are two problems. One is identity problem, and another is the limit problem. Identity problem, we know the sameness in every possible way is a must for anything to be identical with one another. So we cannot say near to 0 is identical with 0 and near to infinity is identical with infinity. Moreover, how could we be sure about the specific number that is now near to 0 or infinity? Anyway, the limit problem is that we should be aware about the use of limit in physical matters. We cannot divide any physical object beyond its physical limit. So for example, if we divide any amount of water up to the subatomic level, that stuff will not be considered as water anymore. So the division must be stopped in some point. And what will be the point, what will be the limit of that division is not determined by mathematics. Another problem, assumption, 1 divided by 0 is equal to infinity, is that mathematical realities do not always represent physical realities, we know. Instead of applying common sense, if we take mathematical findings seriously, so many physically real things will be impossible, and so many impossible entities will appear as possible. For the first kind of bizarre things, Janus paradox could be an example. We know the arrow can reach, but mathematically it cannot reach ever. The second kind of bizarre thing, some impossible things may appear as possible. Suppose we can find a circle with 0 or minus radius. Mathematically, it is correct, but physically it cannot be. We should be aware of the distinction between mathematical reality and the physical realities. Here comes another point, the commutative property of numerical interchangeability and applicability of relational transitivity. So there is a thing, commutative property. If some number, suppose a, is multiplied by 0, will result as 0 on basis of a into b is equal to b into a plus b is equal to b plus a. It's very simple. 2 into 3 is equal to 3 into 2. 2 plus 3 is equal to 3 plus 2. It's simple. The mathematical rationale, if a into b is equal to b into a, then applying the commutative property of multiplication, we can put it in this way: a into 0 is equal to 0 into a. We already agreed that 0 into a, anything 0 is multiplied by anything will result as 0. So 0 into a is equal to 0. So with the commutative property of numbers, you can say that a into 0, that means 1 into 0 is equal to 0. Here comes the question of transitivity, the sensitivity of transitivity. But we know only counting numbers could have this kind of commutative properties. Beyond this mere numerical similarity, transitivity is not that much easy thing. It's very crucial. We know some relations are transitive, some relations are not transitive. We don't know why it happens, but we know for sure that relations are sometimes transitive, sometimes not. Mutual value shifting, which we call transitivity, is grounded in and determined by our intuition or common sense reality, not by the mathematical reality. Matrix is a number system, or you can say array of number. In matrix, transitivity doesn't work. For example, AB is not identical with BA. In Cartesian coordinate, you see also, transitivity doesn't work. Okay, the point R 2, 3 in the coordinate XY, and the point Q 3, 2. These two are the same area, but not the same thing. Okay. If we take it, suppose it's 2 by 3, that means R point is 6 and Q point is also 3 into 2 is equal to 6, but two areas are different areas and different points. In set theory, we can find that two sets could have the same numbers, yet they are not with the same connotation. Suppose EAT, the set has the same members as the set ATE, but they are not with the same number, same connotation. From this, okay, any problem? Okay, no problem. Okay.
Yeah, no problem.
Okay. Okay. So mathematicians. Oh, okay. From this discussion, it indicates that we can assume that identity is more than similarity, equivalence or implication or necessity. So something is equivalent, something is implied, something is necessitated, doesn't mean that it is identical. And issues of multiple realizability is also very much relevant here. We know that we can get the same result in different ways, and having the same result in different ways is not the same thing. From achievement and goal point of view, it could be the same, but the process is not the same. In artificial intelligence, we see that John Searle is arguing for weak AI because he's claiming that he claims that human biological form of causal process in our biological brain cannot be imitated or created in some machine. So multiple realizability is also a matter of consideration here. Mathematicians sometimes prove something in one way and then apply that very specific proof in all the apparently similar ways. This is contentious and debatable. We have briefly focused on it in the above points of 2.B, 3A, and 3B. Okay. If I could have, been able to share the screen, it would be very, helpful for me. Anyway, 0 has affinity with points and infinity. Contrary to infinity, 0 is a real number. Infinity is not a number, it's a concept. But 0 is a unique number. Like infinity, it is mysterious in some sense. 0 is just the divider between the positive and negative numbers. It has no physical entity. Like negative and imaginary numbers, 0 is an ontological assumption. We assume 0. In the real world, there is no 0. There is nothing which exists and which don't have anything, any property. Infinity is also an assumption, but infinity, unlike 0, is not numerical. It's a non-numerical assumption. Come to the point. We assume points from the physical reality of the space. We get the space and we assume the point. The definition we give for the point is impossible, we know. This sort of physical pointlessness of a point is very similar with 0. 0 is also devoid of any numerical value of itself, yet this nothingness of 0 plays a vital role in mathematics. We have seen some examples. Sometimes it behaves as nothing, sometimes it is something, but it is not definable or undefined. We can say from this, from the above sense, 0 is a numerical form of infinity, though 0 and infinity are not identical. In a sense, our observation also says that 0 is the cross point of infinities in either direction. If we assume 0, infinity, but we cannot calculate it, we assume 0, but we can use it in our calculation. So 0 as nothing is a pragmatic ontological concept. We assume it for our calculation to make our number line, for our arithmetic. On the contrary, 0 as something, it is an equilibrium or balancing factor. I have shown a picture here, you see. So 0 has another unique characteristics. Every number, each number must have its multiplicative inverse. How can there be a number without any multiplicative inverse? 0 is a number without any multiplicative inverse. It's an exception, or you may say it is a contradiction. In this sense, 0 is more like a concept than a number. In this specific context, 0 is considered as nothing in the non-existing sense, because it has no multiplicative inverse. You see, I hope you know what is multiplicative inverse. Then come to the point, the characteristics of mathematics from philosophical, specifically from ontological point of view. Math is highly context sensitive. We see it, commutative property and transitivity. It is always conditioned by taken as or for granted factors. In other words, mathematical truths are simply logical deductions of given factors, given by us, by our intuition and common sense. Mathematical axioms are metaphysically subjective, but epistemologically objective. According to Gödel's incompleteness theorem, specifically his second law of incompleteness, he says, in every language expressive enough to describe the properties of natural numbers, there are true statements that are undecidable in the sense that their truth cannot be established by any algorithm. So math has some genuine problems. It is detailed, discussed and, seriously addressed in Gödel's, Kurt Gödel's or Gödel's incompleteness theorem. And in the discussion of 0, it is more concerned and highly reflected, the incompleteness of mathematics. There could be so many philosophical implications of this study on the ontology of 0. Here I am just, pointing two, points. One on Kant's synthetic a priori, it is very well known to us, and another is Lawrence Krauss's notion of nothingness. The first point, Kant's synthetic a priori, the term analytic and synthetic were introduced by Kant in order to contrast two types of a priori propositions. Unfortunately, many contemporary philosophers have taken synthetic a priori much more broadly than Kant took it. They have taken analytic proposition to mean the same as the proposition that is not synthetic. Usually philosophers other than Kant, they have taken what is analytic first, and then what is not analytic, those are synthetic. Kant uses the term analytic since he says the concept of the predicate helps to break up the concept of the subject into two constituent concepts that have all along been thought in it. Kant says analytic judgments, affirmative, are therefore those in which the connection of the predicate with the subject is thought through identity. Those in which this connection is thought without identity should be entitled synthetic. The former as adding nothing through the predicate to the concept of the subject, but merely breaking it up into those constituent concepts that have all alone be thought in it, although confusedly can also be entitled explicative. Okay, I have quoted it from, Smith's, Kant. Anyway, Chisholm formalizes, Roderick M. Chisholm formalizes this in the following way. Okay, suppose something is, analytic. If we say all F's are G's, then the definition should be like that. The property of being F is conceptually equivalent to a conjunction of two properties. F contains two properties, P and Q, such that P doesn't imply Q, Q doesn't imply P. Those two are independent to each other. And the property of being G is conceptually equivalent to Q or P maybe. The following gives us the sense in which Kant understood synthetic proposition. The proposition that all F's are G's is synthetic according to Kant, what Chisholm, formalizes it. The proposition that all F's are G's is not analytic. If it is not analytic, then it is synthetic. Kant held that the propositions of arithmetic are synthetic and a priori. Suppose 2 plus 1 is equal to 3 is not analytic because 3 is not conceptually equivalent to 2 or 1. Okay, and 2 and 1, like the that I have said in the definition, that like P and Q that comprises F, they do not imply each other, but the predicate is conceptually equivalent to any one of them. So this is analytic. So let us consider the examples that I have cited at first. 0 plus 0 is equal to 0. In this example, the result 0, is conceptually equivalent to first 0 and second 0. 0 minus 0 is equal to 0. Here also the result, the predicate is also, conceptually equivalent with a part of the subject. 0 minus 1 is equal to minus 1. Then minus 1 predicate is conceptually equivalent and identical with one part of the subject. 1 plus 0 is equal to 1. In this example also, the predicate is conceptually subject. Likewise, a statement is very much valid arithmetic statement and does satisfy the Kantian criteria of analytic statement. Analyzing the predicate out of the subject is, basic thing. Clearly, it contradicts Kant's claim that the propositions of arithmetic are synthetic. Kant is right in his claim, except for the arithmetic statements where 0 is used. This is the significance of 0. That's why I have discussed 0 as nothing and 0 as something elaborately in the starting of my talk. Lawrence Krauss, he's a astrophysicist. According to him, everything has been created from nothing. A Universe from Nothing is his bestseller book. To his nothingness, indeed, he says that something from nothing may have been required for the universe to come into being. According to him, total amount of positive energy and negative energy in the universe at the beginning of the universe, in the singularity, I suppose, is exactly the same. So if you have plus 5 and minus 5, and that means you have an equilibrium situation, you have 0. This world and the universe has been created from nothing, meaning 0 energy. 0 energy means the total amount of negative and positive energy is always equal. Lawrence, Neil deGrasse Tyson, a famous astrophysicist, has written in the preface of the book, A Universe from Nothing, nothing is not nothing. Nothing is something. That's how a cosmos can be spawned from the void, a profound idea conveyed in Krauss's book. Okay. We see Krauss and Tyson's 0 is not 0 as nothing. It's 0 as something. It's an equilibrium 0, or we can say a counterbalance 0 that we have shown in the diagram earlier. A very meaningful 0. Surely it is not that 0 which is used in the equation mentioned in the above point 1.a. When 0 is not nothing in the usual sense, then the claim that a universe from nothing is quite contentious, misleading. But this is not the focus of our present discussion. Now I'm concluding my speech. 0 is an exceptional and extraordinary number. This brief study of 0 reveals some aspects of the foundation of mathematics. This is also revealing that common sense is based on physical senses, but occasionally it goes beyond the boundary of physicality. Nothing can cancel common sense but improve its quality. In other words, common sense is the base of all sorts of human knowledge, including mathematics. Math is a tool based on philosophical assumptions. Without relevant philosophical support, math is unworking and useless. Some mathematical realities are more metaphysical than physical, or it is purely, we can say, metaphysical. Thank you very much for your patience hearing.
Hello. Thank you. Hello.
Madam,
Hello.
I'm listening. I'm listening.
Oh, thank you for your valuable discussion. You did talk about the contradictory nature of zero, whether it is something or nothing. But your discussion reveals that we should rely on common sense, because common sense is the base of mathematics and all knowledge. So in future, we think that we should have other researches, and we can have a more adequate knowledge about this problem, and we can have a concrete solution. But it is philosophically always there is something that we can think about. We can go beyond these researches and have more and more new advances in that knowledge. So I thank you, Professor Muhammad Mujammal Haq, for your delivery. And now I request Professor Ahmed Jamal Anwar to deliver his discussion about the paper of Professor Ahmed Jamal Anwar of Dhaka University. Okay. Professor Ahmed Jamal Anwar.
Sir, you have to unmute. You have to unmute.
Can you hear me now?
Yeah. We are here.
Thank you, Professor Fahmina Ahmed and Professor Muhammad Muzammil Haq, who happens to be a very favorite student of mine. And the previous presenter, Iqbal Shahin Khan, also happens to be my student. Thank you very much for presenting a paper on this topic, interesting topic. Not actually go through all the full paper. I had a very hard look at this. I am really delighted that you have written a paper in mathematical philosophy of mathematics. But I couldn't follow in some parts. I couldn't follow your argument in some parts. For example, once you said that two sets containing the same elements may not be equal or equivalent. Equal sets and equivalent sets are not the same thing. Two sets may be equivalent without having the same elements, but having the same number of elements, may make two sets equivalent. Equivalent sets and equal sets are different. So if you form a set with the three elements E, A, T, and you form another set with the same three elements, but arranged differently, like A, T, E, then the two sets are the same sets, because they have the same elements, only they are arranged differently. And their cardinality is also the same. So I couldn't understand this point, actually, your argument. Actually, as Professor Whitehead, professor of mathematics at Cambridge University, and who was the co-author of a famous book in mathematical logic with Bertrand Russell, Principia Mathematica, Whitehead. He's a great logician as well as a mathematician. He said that there is a lot of confusions among philosophers and other people about the concept of, about the number zero, because zero is a very special, as you pointed out, zero is a very special number and a specific number. Ordinarily, we do not go to the market to buy zero fish, or, I have zero money. These are not in normal everyday use. So ordinarily, people are very much confused about this number. And one mathematician, I don't remember the name, said that God made the natural numbers, the counting numbers, 1, 2, 3, 4, 5, and man made the rest. So, numbers are defined through our imaginations, but they have also very important applications in real life. Think about the negative numbers, -1, -2, -3. We don't say that I have -5 taka in my pocket. These things are not always directly applicable in real life, but because of the man's ability to think abstractly, has made them able to define many numbers negative numbers, and fractional numbers, decimal numbers, and zero, and so on. And the discovery of this, in the other notation system, Roman number system does not have zero in it. But the Arabic notation system has introduced this symbol for zero. And this has vastly developed our ability to make calculations. Without zero, we could not do many of the calculations that we are doing. Modern civilization would not have been possible without zero. The contribution of zero is unestimable in our modern civilization. So it's very important indeed. And as Muzammal has pointed out, many of the important properties of zero. We know that 1, 2, 1, 3, 5, 7, 9, these are odd numbers. -1, -3, -5, and -7 are also odd numbers. And 2, 4, 6, 8, 10, -2, -4, -6, -10 are even numbers. Now question may be raised, is zero an even number or odd number? Some people will momentarily say, oh, it is neither odd nor even. But actually it has to be accepted as even. And there are 5 or 6 different reasons why we should count zero as an even number. I cannot explain these reasons here, it will take time. And moreover, we can just use an intuition to understand that zero is an even number, because an even number is a number which on the number line lies between 2 odd numbers, because 3 and 5 are 2 consecutive odd numbers. Between 3 and 5, the only positive integer, only whole number is 4. So 4 is a even number. Between +1 and -1, +1 is an odd number, positive odd number, -1 is a negative odd number, because between -1 and +1 is 0. So 0 has to be counted as an even number. And so an even number is one which is always between 2 consecutive odd numbers, So this is a very interesting property we have to accept. For example, 0 factorial is equal to 1 factorial. But 0 is not equal to 1, but still 0 factorial has to be accepted as equal to 1 factorial. Why? There is a mathematical reason. So, when we want to apply, to me, it appears that 0 also indicates something which is real in our life. Not only positive numbers, not only negative numbers. 0 also indicates something which relates to. In fact, 0, 1, 2, 3, 4. Any number is an abstract entity, is an abstract concept. No number has any, if I say 3, 3 does not mean 3 pencils. 3 does not mean 3 human beings. 3 does not mean 3 pieces of stones. 3 does not mean 3 footballs. 3 can refer to any, set of 3 objects. So 3 is different from 3 books. 3 is different from 3 pencils, and so on. 3 is an abstract number. Similarly, 0 is also an abstract number. 0 refers to a situation where we indicate the absence of something. But the absence of something is also a situation which has to be described with a symbol. So all numbers are actually symbols. And 0 is, 0 represents a real advance in the ability of human being to think, abstractly. So in that sense, we don't consider 0 as, totally different from other numbers. Although 0 has its own specific properties. For example, 1 plus 0 is equal to 0. 0 plus 1 is equal to 0. And 1 into 0 is equal to 0. 0 into 1 is equal to 0. That is the commutative principle holds in case of only multiplication and addition. But in case of subtraction and division, the multiplication, commutative property with 0, right? So, it depends. And also he talked about another important thing, incompleteness theorem, Gödel's incompleteness theorem, which is, epoch-making contribution in mathematics and science. We know also in logic, in quantification logic, there is no any, it has limitation. We may find out a theorem in quantification logic which may not be decidable within the system. We may have to go beyond the system. But in truth functional logic, it is complete, it is complete. But quantification logic is incomplete, because incompleteness means that within the system, you can find a theorem which may not be provable. We have to introduce, more concepts and more assumptions. That's what we mean by incompleteness. So incompleteness is something which characterizes mathematics as well as symbolic logic. This is important, and we must recognize the importance of, symbols. For example, Whitehead said, I can read it to you. Whitehead said in his introduction to mathematics, by the aid of symbolism, we can make transitions in reasoning almost mechanically by the eye, which otherwise would call into play the higher faculties of the brain. Suppose, think about the simple mathematical formula, a square minus b square equals a plus b into a minus b. Even a student of class 5, 6, or 7 can easily understand this formula and apply it to solve many mathematical problems. But if you explain the same formula in terms of ordinary language, like the difference of the squares of two numbers equals the product of the sum and division of those two numbers. This is very difficult to understand. No student will understand this, statement. So symbolism is used to help us understand and clarify and remove ambiguity in our thoughts. It's not used to, mystify. It is rather used to simplify things and help us to think clearly and unambiguously. So zero is indeed a great contribution in mathematics and in modern civilization. It has, so the symbol of zero is also very important and helps us to understand.
I'm not listening, Professor Jamal.
You cannot hear me? Can other people hear me? Dr. Shazan?
Yes.
Can you hear me?
Yes. Yeah. You are audible.
Muzammel, can you hear me now?
Yeah, we can hear you very clearly, sir.
Very
I
clearly.
can also hear everybody. I can also hear Muzammel, but I don't know what is the problem with me or him.
No, we are listening to you. We
yeah,
can hear
that's
you.
fine.
Yeah.
Maybe something is wrong with Muzammel. Professor
Yeah.
Oh,
Professor Muzammel, try to fix your...
I can see also Dr. Lutfur Rahman, another of my students there. I didn't see you earlier. Thank you.
Okay, finished your lecture, but Kamul, I think it's
yeah.
very good paper indeed. But as I had a very hurried, quick reading, I couldn't.
Yeah.
And Muzammel will answer some of my,
But
concerns.
I see Professor Manzoor Ilahi is asking you a question, but I asked Kamrul whether you can have time for answers, questions and answers.
Yes. Okay, I think it's 9:30. So we have another paper to present and to have discussion on it. So I think if we allow 2 questions, and it's a good idea if presenter and discuss and answer this question using chat box. That will be a good idea. You can ask for 2 questions and.
So it is time.
I tried to contact Muzammel.
Sir,
I guess.
I can see a hand. Professor Norman Suajo, have you got any questions? Ma'am, do you see? Yeah.
Hello. Yes.
Hello. Yes.
Hello. Yes. Thank you. I'm definitely out of my element trying to think about what has been said in this particular discussion, but it's very interesting. I found the title of the paper very, very interesting. But it reminds me of my graduate student days in a philosophical logic course. And I would ask Professor Mujamil, isn't this really a matter that can be handled in terms of how you decide what is important for you in terms of the syntax, the semantics, the pragmatics of what it is you're trying to ask here? And so if you deal with it in that perspective, then you have your answer one way or the other. And issues such as Zeno's paradox don't matter because you have a particular interest in what you're saying formally in the syntax. You have the meaning that you're trying to clarify, and there's a particular purpose with what you're doing with it. And that will vary according to the individual's particular purpose. Is that not the case?
Mm-hmm.
Okay. Yep.
Mr. Ken, this is a very big, this answer would be very big. So you can, Professor Mozammel, can you briefly explain the question asked by Mr. Suajo?
Yeah. Ma'am, it will be better if let the another question be raised, and I will answer it all together with the points raised by Professor Jamal.
Yeah, we have another question on the chat box, so you can have a look and answer both questions.
Both questions.
Allow, yeah. If men allow, you can, yeah.
Yeah, I allow. You can answer both these questions at same time.
The second question is raised by Professor Manjur Alahi. So you have a look and answer both the questions, please. We are running out of time though, so.
Yes, very. Nobody will have patience to hear the second paper.
Yeah. Thank you, sir. Yep.
Okay. Professor Mozammel?
Yeah. I was waiting for Manjur Elahi to this question.
Okay, no. That's in their chat box. So I can read that out for you.
Oh, you can.
Okay.
Yeah, Kamrul can. Okay.
Yeah. The question was on to Ahmed Jamal Anwar Saddo, but you can answer it. Whether the number 0 and Sunnah in Indian philosophy carry the same meaning. So 0 and Shunno.
Yeah.
Do they carry the same meaning? That is the question. Okay, please.
Professor Jamal can answer it better.
Okay.
Okay, sir. Do you think that?
The two questions. Yeah.
I have no idea about the concept of Shinno in Indian philosophy, so I will not answer that.
Answer that question. So, Mr. Mozammel, you proceed on.
Yeah, please. Thank you, Professor Jamal Anwar sir, to deliver a very nice discussion. And actually, you supported me in all the points. The points you didn't raise any, serious objection. I was really afraid of because I'm your direct teacher. You are my direct teacher, and I am your direct student.
Can I interrupt, madam, to Professor Mozammel? Just one question. I'm confused whether Professor Jamal Anwar told that it is an Arabic concept, 0. As far as I know, it is an Indian concept. Can you clear it, whether it's an Indian concept, then it brought back to Arabic, and then it went back to India, Europe? What is the root
actually,
of that concept?
Professor Elahi.
Yeah.
Actually, the history of 0 is, is different thing, I suppose, and I don't have any clear-cut, idea about that. I'm sorry to answer your question.
Okay, thanks.
Okay, so
0 is built as a number only in the Arabic notation. Before that, it was not used as in a system of notation.
So. Okay.
Thanks.
So, Professor Jamal has pointed out the two sets are, equal and equivalent, the distinction between then cardinality. Actually, my point was that the commutative, property that is used in some numerical, equations is not the same thing that we use transitivity. And even transitivity itself is, it is not applicable in all the situations. In which situation it will be transitive, and which situation it will not be transitive. A bigger than is a transitive relation, father of is not a transitive relation. Why it is that? I'm focusing that very thing, the common sense, that is our intuition. And whatever has said Whitehead, I do agree with him. And actually 0 is a number, even number. If we divide an even number, we get an integer. And if we divide 0 by 2, we get 0, and 0 is an integer. In every sense, 0 is an even number. But in some sense, 0 behaves as nothing. In some sense, 0 behaves as something, whatever that thing. So, what is 0? 0 is unique number, and it has similarity with points. It has similarity with infinities, but it is unique. And actually, we assume 0. There is nothing that you have said 0 in the real, life. We assume, and this power of abstraction, this sort of imagination, we have been able to build this civilization. Without this sort of imagination, it would be impossible for any development. Anyway, what is the regulation of the imagination? Philosophy regulates the imagination by logic, by epistemology, by all the philosophical tools and methods and everything. So the very imaginative faculty of human being that is used in mathematics is actually the area of philosophy. Anyway, the importance of symbolism is obvious, and about the incompleteness theorem, it's very interesting. And the limit of science, we can understand the limit of science by this incompleteness situation. Sir, please.
Jamal, there is another question from Shamsullah. Can it would be entertained?
But we are running out of time. So if we take just half a minute, we can.
We know that the transitivity relation does not always hold. In some cases, some relations are transitive, some are intransitive, some are even non-transitive. That is what we understand. But on what particular relation are you applying the transitivity property?
Yeah. In mathematics, we see. We see sometimes the commutative property is used, which is a form of transitivity. And actually, I'm focusing on transitivity. That transitivity is not, a very silly thing. It's very sensitive. Sometimes it is transitive, sometimes non-transitive, sometimes intransitive. But what makes the difference? This is the main focus. This is the intuition. This is the common sense. This is our grounded in our rationality. Whatever the rationality the paper in Professor Norman about rationality, and you have said about the bounded rationality. That's different thing.
We know that, but in this case, on what particular relation are you referring the transitive relation to?
Yeah. Oh, it's in my paper. Just a second. Okay. Suppose 1 into 0 is equal to 0. Because, A into B is equal to B into A. On basis of that, we can say that, 1 into 0 is equal to 0 into 1. And we know that 0 into 1, anything, 0 is multiplied by anything will be 0. So 1 into 0 is equal to 0. So we get this result on basis of commutative property. And this commutative property is used in mathematics, but it doesn't work all the time. In all the cases, similar cases, that I have said in my comment, that similarity, just mere similarity, doesn't matter. Okay, mathematicians sometimes prove something in one way and apply that very specific proof in all the apparently similar cases. But from philosophical point of view, we can raise objections. That I have raised objection, 0 divided by 1, it could be 1 and 0. Why it should always be undefined? If we start from 1, it will be one result. If we start from 0, it could be another result. So the result oriented and the there could be different perspective. If I have one thing, I don't give anything, then 1 could be the result. If I have one thing, I don't give you anything, then from your perspective, you've got nothing, so 0 could be the result. From which context actually we are thinking about is more important, and Professor Norman has actually pointed on this issue, that how we decide is more important as far as I understood. Thank you very much.
Thank you for answering the question, Mr. Muzammil, and also the discussion, Professor Ahmed Jamal Anwar, for your valuable discussion. Sorry,